Hello, everybody. So since we were unable to meet due to the inclement weather, I'd like to introduce you to some Chapter 1 concepts. So let's take a look here at the PowerPoint here from Chapter 1. So I'm going to also post a worksheet that you can fill in some blanks along the way as we go through the material from Chapter 1. And that worksheet can be used as a study guide. It's actually from the publisher, from Pearson, so it should kind of correlate with the material that we cover fairly well. So chapter 1 here is about matter, measurement, and problem solving. I'm going to make some videos that kind of group together some key concepts. So this first video here kind of introduces us to, what we're going to find this semester when we talk about chemistry. So they pose a question here as to what the most important idea in all of human knowledge. So they're kind of biased in their question here, where they say they limit themselves to a scientific answer, and really biased in the sense that it's very much a chemistry type answer, that the properties of matter are determined by the properties of molecules and atoms. So as we go kind of smaller and smaller down to molecular scale or atomic scale, we see that what we see on a macro scale level or a large scale, what we can see with our own eyes, non-microscopic things, not submicroscopic, but what we actually experience deals with different properties that go all the way down to the atomic level. So we get these tiny little components of matter, and that contributes to our reality here. So as I just mentioned, atoms and molecules determine how matter behaves. So matter is anything that we see, that we touch, that we can feel, anything that takes up space and has mass. So it contains atoms, it contains these building blocks of matter. So water, the properties of water are determined by the fact that there's one oxygen, two hydrogens bonded together. So this produces a type of physical property. These different bond types, properties of sugar molecules also dictate how sugar behaves, whether it's crystalline in structure. So we're going to look at some different ways of classifying matter. So atoms, as noted here, are the submicroscopic particles. So beyond what a microscope can see. So a microscope brings us down to maybe like the cellular level, but we need a really strong type of microscope, like a scanning electron microscope or a transition microscope, TEM, SEM, something like that, to see down to individual atoms. So we can see this small, these building blocks of matter. But note that atoms in general, these free atoms, as they're called here, do not really exist in nature. For the most part, atoms will react and form compounds and bind together and form what are called these geometrical arrangements here. So they make different shapes, they make different geometries, and then they form molecules, and the way that they interact with other molecules dictates, what we see in life here. So here's a water molecule here. So I mentioned that we have that oxygen atom. That's what we see on top there, that red ball. We're going to see that chemistry textbooks love to give color coding to different elements. So oxygen tends to be red, hydrogen tends to be white, carbon will be black, nitrogen blue. Let's see what else. Sulfur is usually yellow. And then chlorine and halogens like fluorine tend to be green. So just when you're looking at these molecular representations here, just note that a lot of times they don't tell you what the atom is, but they give you a color coding. So liquid water, water vapor, gaseous water, and frozen water, any phase of water is composed of water molecules. They just might orient themselves differently depending on their temperature, which would result in different phases. So we have, again, liquid water molecules are what we most, think of when we think about water, not always water vapor or the frozen ice phase of water. But we always have this same ratio, this 1 to 2 ratio of oxygen to hydrogen atoms. And that's what makes water water, its identity. Um, so we want to define, behavior, predict and understand behaviors based on, atomic interactions when one atom is bonded to another, and then molecular interactions. Once those atoms are bonded together, we make molecules, and then how molecules interact. And these are, not only the building blocks of matter, but really the building blocks of life. So we should have some interest in these concepts. Now we can see that we can have the same element and it can present itself in different ways. So what we see here are different representations of carbon atoms. So on the left-hand side here, we see the structure of graphite. So those black balls that I mentioned will represent carbon are oriented in sheets so they can slip across one another. So if you know that your pencil, the lead, quote unquote lead, it's not really lead because that's pretty toxic and you don't want to be chewing on a toxic substance. You don't want to chew on graphite either, but if you accidentally put it in your mouth, it's not as deadly a consequence. But anyway, these sheets of graphite, that gives the pencil its functionality so these sheets can slip onto your paper. Um, and versus diamond here, the molecular structure on the right, we can see it's actually this kind of crystalline repeating pattern, or this covalent network rather of these carbon atoms bonded to one another. But it gives it this rigid structure where the different properties we see between diamond and graphite would be, a different strength of, the graphite kind of slips apart, where the diamond is one of the strongest materials that are naturally occurring. So again, depending on not only the atom and the way that it's connected, or rather the atoms being connected to one another, but the way that they're connected can also dictate some physical properties. So we're going to wrap up here in this introduction. Please reach out by email or ask questions during class if you need further clarification of anything from this first part of chapter 1.